Assalamualaikum warahmatullahi wabarakatuh. My name is Salimah Binti Nasir. My metric number CE190189. I'm my supervisor is Ts.Dr. ANIDA Binti JUMADI. So my title for my project is Estimation of Cobb angle for C-curve scoliosis X-ray image using processing image technique. Project background. Scoliosis is a three-dimensional structural abnormality of the spine, commonly seen in 2% until 4% of the absolute population and 70% until 80% of the causes of scoliosis are known with certainty. In addition, scoliosis patients cannot lift heavy object and cannot play strenuous sport. And based on shape of curve, scoliosis can be classified into two types, namely is C curve and S curve. It's also family illness and family history and illness are collected to determine the expected prognosis. This is the example of C curve and S curve scoliosis. The problem statement is the previous method to determine the scoliosis by using sum of square difference, which is SSD, to determine the curvature. The SSD calculate submission of the square for the pixel subtraction between template and source window, and from that it create the equation to get the x direction and y direction for estimating scoliosis as X-ray image. Another way to determine the severity of scoliosis is by measuring the Cobb angle. Traditionally, the doctor will observe or check the curve of scoliosis patient by using manual protractor based on the X-ray film. Last, for problem statement, the research proposed the use of signal processing method to detect the Cobb angle of the curved scoliosis based on X-ray image. Objective of this project to determine the region of interest, which is ROI of spine, thoracic and lumbar segment in scoliosis patient, C-type curve. To determine the Cobb angle based on inverse cosine, to evaluate the proposed image processing solution by comparing with the semi-manual method. Scope of study for this project is first, the type of scoliosis that was chosen in this study is C-curve. Second, the suitable pre-processing image and edge detection technique were studied for spine ROI estimation based on thoracic and lumbar segment. Third, the formula of triangle method was implemented to assist the estimation of the Cobb angle. The coding for MATLAB software will be focusing on estimating the degree of the curve, which is 10 degree and above. Fourth, 5C scoliosis X-ray image were used to test the development algorithm. These images were collected from the Pusat Kesihatan Universiti Tun Hussein on Malaysia, which is PKU UTHM. Last, for scope of study is for the validation purpose. The purpose method was compared to the semi-manual method by using only software and observation from the radiologist expert. Next, this is the proposed general algorithm process for this project. As you can see in figure 4, we will start with re-image and pre-processing image. Next, we will go to manual cropping to get region of the vertebra. Third, mark seed point from the crop X-ray image. Fourth is vertebra detection by using HAR to get automatic point. Last but not least is calculate Cobb angle from the curved triangle formula based inverse cosine formula. Next, for the methodology part is the main flow chart for this project is, as you can see in figure 5, we will start and then select select and read the image, and it is grayscale or not. If not, we have to convert to the grayscale. If yes, we just continue to the pre-processing image. And after that, we have to crop image, and then we have to mark 3 points at the vertebra, and it will ask enough of 3 points. If yes, we have to we continue the centroid deformation using hull cascade. If not, it will turn back into the marking 3 point. And last but not least is it will Cobb angle will be determination. For subject 1 is the last after marking point. It will calculate automatically and pop out the value of the angle. And then the other side is the Cobb angle by using inverse cosine law. The technique purpose that have been choose and I've been do is 3 reading. And the last I will calculate the average of the reading each of the subject. Next is this is the comparison between proposed method and ONI software. As you can see, all the subjects have been less than 5% error. And if as you can see, for the subject 1, the percent error is 0.4, subject 2 is percent error is 2.5, subject 3 is percent error is 3.6, subject 4 is percentage error 1.2, and last subject 5 is 3.7. Next, we go to the result analysis. Analysis of analysis of the processing time. As you can see, in the ratio of time taken, the proposed technique more than faster under otherwise is only software. As you can see, only software is have to do more work, whereas the proposed technique that it have to mark 3 point only and calculate calculate automatically of the Cobb angle. Demonstration part. So this is the coding of the Cobb estimation, which is the Cobb angle, and then we click run. Then after that, we have to choose the image, choose the patient one, and then it will pop out as the Scoliosis X-ray image, and we click OK. After that, we have to choose the part that we want. And then it say we have to mark 3 points. And 1, this is the apex. So 2, and last is 3. Then we have to click the continuing. Yes. And after that, it will show out the value of the Cobb angle, and this is the central estimation part. That's all from me. Thank you.